And then for this announcement, you know who you are. You are invited to the academic celebration tomorrow on Thursday. We need you to RSVP as soon as possible can. Let your peer mentor know, let somebody know that you plan to go to that. So some of you apply. We're invited to that academic celebration and want to go. Please let somebody know. Okay, and the last announcement, more roundtables. More roundtables. Okay, are we ready? Okay. So today's lecturer is Dr. Jeff Baldwin. He is professor of geography and global studies here at Sonoma State University. A very popular professor, and I think you'll get a taste of why today. We invited Dr. Baldwin to give this talk because he's an expert on globalizing economies and on the interrelationships between humans and their environment. And in his own words, he says that he's particularly interested in the ways in which environmental communities provide services to human economies. Okay, but I don't think I need to say anything else because you can just think about that sentence probably for 50 minutes which one is wrong. We hope Dr. Baldwin will help you think differently about the relationship between people and the environment, and more specifically that his ideas will help you forward your country studies that you are in the middle of. So let's give a warm welcome to Dr. Baldwin.
Hi, thank you. It's working. Okay, technology. Hi. These are 3 questions I formulated for you to think about while you're watching this, thinking about this. This is going to go fast. I want you to pay attention to the overview and try not to get lost in the minutia. Do we get to put the PowerPoints up on Moodle when we're through with them so they can look at it again? So if there's details you want to look at it then. What I want you to do is try to stay up with the larger train of what I'm going to talk about today, because there's a lot of detail here we're not going to get into. Take one of my classes, we'll get into the detail. There's this. For over 200 years now, people have been thinking, gee, people repopulate very, very quickly. And as a result of that, we may very well run out of food. Right? This starts with Thomas Malthus a very long time ago. And this has been an issue for a very long time. And humanity has struggled with this issue for a very long time. How do we provide for this many new people? Can we make enough food for them? Thomas Malthus, 1798, comes up with this idea, observing what's going on in London at the time, that population is growing rapidly. Food production is also increasing, but it's increasing at what he calls an arithmetic rate, a bit each year. Right? The problem is that human populations, and if you read Thomas Malthus, he is an incredible classist. He blames this on poor people. This is not a rich people's problem, so that may sound very modern to you, but it's been around for a long time. Humans, especially poor humans, regenerate at a geometric rate. Each 2 begat 4, those 4 begat 8, those 8 begat 16, 16, 32, 64, 128. And in 100 years, you've quadrupled your population. But we haven't quadrupled our food supply. So what Malthus was concerned about, and what we have now is neo-Malthusians are concerned about, is that population is going to outstrip food. And when that happens, what we're going to get is starvation, famine, horrible things. It's a bad way to die, starving to death. It's slow, it's painful, it's ugly. So we want to avoid that. But it never happened. It has never happened. Globally, we have had enough food to feed people. Globally. Now, there are lots of people in the world today, over 1 billion people in the world today, who cannot afford to buy enough food, and so they don't get enough food. But it's not that there's not enough food out there. It's simply those people don't have the money to buy the food, right? So that's what's causing hunger these days. This is the population growth curve for the human race. This is 2,400 years ago. This is 2,000 years ago. We've got about 150 million of us monkeys around here, right? We go forward to about 900 AD, and we double. We go forward to about 1500 AD, we double again. We go forward to 1800 AD, we double again. We go to 1900, we double again. So how many people are on SSU's campus today? About 10,000, right? 10,000. This would be like tomorrow, if we went to the edge of that curve, having 10. 350,000 people on our campus. That's the change. That's the change, right? And it's happened in a relatively short time, mostly in the last 150 years. Good news is, it looks like we are slowing down. Globally, the number of children each woman has is decreasing, decreasing, decreasing. We're getting closer to that 2.1 children for each couple, which is replacement. And by 2050, demographers think we're probably going to start maybe even tailing off, right? At around, now people are thinking 10 to 11 billion people. We have about 7.5 billion now, so another 50% increase. What about food for all these people? How are we going to do this? How have we done this so far? And this is what I want to talk about today. How have we made food in the past, well, since World War II? How has that changed in the past 50 years, 40 years, 30 years? After World War II, the United States sort of becomes world leader. We help establish the United Nations. The first meeting is in San Francisco, California. Yes, that's where the United Nations begins. And President Truman says we need to aid the rest of the world in their development. So the United States is going to lead this with the help of the Rockefeller and Ford Foundation, charitable foundations, much like the Gates Foundation today is very big. These foundations were huge back then. This is 1949. We're also going to get research universities on board with this. How can we grow more food, right? Why not enlist our brightest people working at universities, provide grants for them so they can figure out how to make more food, same resources. And then we're also going to get United Nations groups involved with this. So we set up a group humanity, a group in Mexico to look at how can we grow more corn, right? So we get a corn institute in Mexico. But corn's only grown more in Africa and South America. In Asia, it's about rice. And so they set up a rice research institute in the Philippines, right? And all these research groups do is figure out how can we grow more rice, how can we grow more corn. We also have the Food and Agriculture Organization, the FAO, still extremely active in food issues around the world. We also get the World Bank. And the World Bank is about lending money to governments for big infrastructure projects like dams, because you can't have a big irrigation project if you don't have any water. And one way to get water is have a big dam, right? So that's what the World Bank does. They focus on 5 specific technologies. I'll show you these technologies. Pesticides. In 1949, we were losing about 15% of our crops to weeds, to fungus, to insects, pests, right? And so we make these chemicals that kill pests. Now, prior to World War II, we didn't have very many chemicals that killed pests. It's kind of a new thing, organic chemistry. So we do that. We also do irrigation, right? There are all these lands that have lots of sunlight. It's not freezing cold, but it's dry. If we could just get water there, we could grow food there. Not only that, but we have lands like, oh, I don't know, the Central Valley of California, where on a good year, you don't have to irrigate. But on a bad year, if you don't irrigate, you're screwed, right? So maybe I don't need the dam and the irrigation this year, but I might next year. So this is backup. This provides a safety against drought. Second technology. If it is light yellow, there's irrigation. If it's reddish, there's a ton of irrigation. Look how much of the earth is irrigated. Now, you notice Antarctica is not irrigated. We don't grow crops there. Okay. But, it's not even on there. That's how important it is. But around the tropics, especially the temperate zones, lots and lots of our lands are irrigated. And this means more food. I'll show you how much more in a minute here. Fertilizer. If we can put the nutrients on the land that the plants need, especially nitrogen and phosphorus, those are the first things that sort of run out in the soils, well, then we can grow more food in the same amount of space. This becomes a very important technology also. I'll problematize these in a minute. Mechanization. Well, in much of the world, even today, most farming is done by handwork. It's labor by humans, right? You can do the same work cheaper with petroleum. For now. We'll see what the price of petroleum does in 20 years, but for now, petroleum's relatively cheap compared to humans. So let's get the humans off the farm and let's use machines. Where do the humans go? Oh, I hadn't thought about that. That's right. Okay. Well, they got to go someplace. That's another class, okay? Something to think about. Where do the humans go? We're also going to have better seeds, better plants. Now, farmers, since we started farming, have been making better plants, right? You grow a field full of oats, and you look around, and have you noticed that kids look like their parents a little bit? Yeah, you notice that? Okay. Well, people figured out early on that the child of that plant looks a little bit like that plant. And so the plants that produce the most, I'm going to save those seeds. I'm going to plant those next year. And then my whole field is going to look like that. And I'm going to find the best plant in that field. I'm going to save those. I'm going to plant those next year. And I get better and better and better plants. It's called seed selection, seed saving. This is what farmers have done for over 9,000 years. And the reason we have these wonderful plants that we have now is farmers have done this. Now, about 100 years ago, in research institutions, land-grant universities like Davis, California, we started having scientists do the same thing, right? And that's all they're doing is they're saying, well, gee, if I could take this trait, maybe this type of rice is a little frost resistant. And this type of rice kind of does better with less water, right? If I could do that, then I could start growing and blend these two together. Maybe I could start growing rice at a higher elevation where we might have some frost and it might be a little bit drier. Smart, right? Off we go. Making new seeds. Okay, technology. So it's like this. We get this plant that's really stocky, which may be something we like because it raises the plant up a little bit. And then we get a plant that has lots and lots of seeds, but maybe it's not resistant to bugs. We put them together and we get super plant, right? And this is about combining pollen. It's just rubbing the pollen together. You do that enough times, the seed becomes stable, and you get a new strain. Okay, how much has this increased? Well, top bar up there, I've got how much fertilizer has increased from 1960 to 2005. And you can see that fertilizer use has increased from about 20 million tons for nitrogen fertilizer. Well, that's over a 4-time increase. And phosphorus is nearly doubled, right? Irrigated land has gone from 125 units, whatever that might be, to, I don't know what's the, million of hectares, to, well, it's more than doubled. It's more than doubled. We have over 300 million hectares in irrigation now, right? So more land being irrigated, more food production, more secure food production. Pesticides. 1960, we didn't hardly produce any pesticides. The industry was still new. Now we're producing $15,000 million worth. That's $15 billion worth, right? Pesticides. So this has worked. What has it done for food supply? This is per capita food produced globally. How much food is produced on average for every person in the world? 1961, it was about 2,100 calories, 2,150. Do you ever count calories? Can you live on 2,150? So I'm getting girls doing this, I'm getting guys doing this, okay. And there's a reason for that. Men tend to burn more calories. The bigger bodies need more calories. But guys, can you get by on 2,800 calories a day without gaining weight? Yeah, most humans can do that. Most humans can do that. 5 years ago, globally, we produced about a little over 2 pounds of grain for every human in the world. 2 pounds of grain. Can you eat 2 pounds of grain in a day? Right, this would be a big loaf of bread. Every day, can you do that? I mean, you could do it, but that's a lot of food. Is that enough food? Now, that doesn't include vegetables or fruits or meat or pulses, soy, beans, that stuff. Doesn't include that. Do we have enough food? Yeah, we got enough food. We got enough food. Not everybody can buy it, but we got enough food. That's a problem. Okay, limits to this. Well, one is our footprint. How much land are we taking to do this? So a couple of illustrations here. Where it is very dark red, almost black, that means in those areas, humans are consuming 100% of all the plant growth in that landscape. If there's a plant growing in that landscape, humans are biting it, right? Right, 100% of all production by plants. Now, there are areas where it's much lower than that, but boy, there are lots of areas where we're consuming almost everything being grown. Globally, humans eat 40% of all the plant growth produced in that year. That leaves 60% for all the other animals out there, right? We consume 40% of the environment. We can kind of do this through a cartoon. This cartoon shows the mass, the weight of various land mammals for all the world, for all the world. Now you see there are some green dots there. Those are non-domesticated animals. So all of the elephants in the world, weigh this much. All of the elephants in the world weigh this much. All of the humans in the world weigh this much. All of the cattle in the world weigh this much. Elephants, cattle. All of the sheep in the world weigh this much. All of the goats, that much. Pigs, that much. You get the idea. We're kind of crowding everybody out here, right? This is becoming a very human-centered kind of system we've created here. And this is how we're producing food. We're crowding out everybody else. So what if you need to eat? and you're not a goat or a sheep or a cow or a human, well, good luck with that. Okay, technology limits, problems with technology. Let's take a look at this. Pesticides. Now, pesticides work because they kill things. Okay? Are you a thing? Can you be killed? Okay, maybe we should look at this more carefully, all right? So let's look at this a little more carefully. This is how many metric tons, millions of metric tons have been produced pesticides. And pesticides include herbicides, which kill weeds, and fungicides, which kill fungus, and insecticides, which kill insects. These are all pests, right? So in 1940, we didn't produce any, hardly to speak of, right? And now we're over 3 million metric tons of pesticides, things that kill things, living things. This is atrazine use in the United States. The redder it is, the more there is. But look at this, just to bring it down to scale. Corn in the United States in 1997, this is the latest, date I could get, 62 million pounds of atrazine was applied to our corn crop. 62 million pounds of atrazine. Could you eat that much? That's a lot, right? 62 million pounds, okay, of atrazine. Atrazine kills things by telling it to grow. It kills weeds. You spray it on the weed, and the chemical says, weed, grow, grow, grow. Does that make sense? Do you want your weeds to grow? What if you grow to death? What if you grow so fast your vascular system can't keep up with you? You're suddenly 10 feet tall, but your arteries are only 6 feet long, right? You die. It basically tells the plants to grow so fast that they starve themselves. Their vascular system can't keep up. Dead plant, right? Makes sense? So basically, we're encouraging unregulated cellular growth. Can you think of any diseases in humans that are related to unregulated cellular growth? Thank you. Cancer, yes. Cancer, yes, exactly. Cancer, cancer, cancer. Studies directly linking atrazine and other xenoestrogens to human cancers are a little difficult. And I'll show you why in just a minute here. It's partly the way the scientific method works, but I'll show you that. This is breast cancer incidence in the United States. It's gone up. Ovarian cancer has gone up. Other cancers have gone up. Breast cancer. Women, are you concerned about this? Yes. Men? Sperm counts have been going down. About 1% a year since about 1920. 1% a year. Less sperm, less sperm, less sperm, guys. Okay? And this is not about underwear. Okay? This is about other things going on in the environment. This is exposure to atrazine. Oh, thank goodness it's not us, not my problem. Right? But if you live in Texas or Kansas or Nebraska or Nevada or the Central Valley or Ohio or Maryland, you're being exposed to a lot of atrazine. So is it safe? Well, let's test this. And we're going to test this using the scientific method. And the scientific method, I'll show you in a minute sort of how this works. But to elaborate, I love these guys, these two guys, George Lakoff and Mark Johnson, because they look at us and try to figure out how we think. One is a cognitive behaviorist, and the other is actually a philosopher, but he does behavior too. So in 1980, they published this book called Metaphors We Live By, where they're actually thinking, they're looking at how do we think? How do we organize our perceptions of the world? And they come up with this. Causation among humans works this way. This is how we deem if there is causation. 1, a specific agent acts on a specific object. So if you can't tell who did it or what did it, yeah, it doesn't really compute. We don't see it that way. And it's got to affect something that we're looking at. And if it doesn't, then we don't really see it that way. Right? Now, if it's a human agent, 2 and 3 come in here. If it's a non-human agent, not so much. So maybe not the scientific version method, but this is how we think about this. The agent has to act with intent and control. If you do not act with intent or control, then you're not really having causation. So if somebody accidentally runs over a 3-year-old and kills her, do they get the death sentence? No. What do they get? You might get 3 years. Now, if I meant to kill her and I run over her, what do I get? Life in prison. Does the girl care? She's dead either way. Interesting, isn't it? Isn't it? The agent is responsible for the action. So if I'm really drunk and I do it, then I'm less responsible, right? I'm driving drunk, but I'm less responsible. Young man plowed his pickup truck into a car parked at the end of Highway 12 last year, killed 2 women in the back seat, lovely people, got 2 years for it because he was high. Right? We think this way. Okay, back to the scientific method. Number 4, the agent physically touches the object with its body or an instrument. In other words, yes, I can see it. I'm doing it. I touch the thing. I affect it. And number 5, the resulting change is physical and perceptible. This is the scientific method. This is how we think scientifically. This isn't how we think normally. This is scientific thinking, right? We think more intuitively. Does the sun go around the Earth? Well, why does it pass across the sky every day then? Now, you know the Earth is revolving, don't you? Yeah. You know that? Yeah. Can you feel it? If I jump, do I land in the same place or do I hit this place? No, we can't feel it. It's not perceptible. On a day-to-day sort of functioning, I do it. I kind of think of the sun passing through the sky. I don't think about me going underneath the sun like this. That's not how I think. That's not intuitive, right? Science tells us no. We can observe this. We can see further into this. What I'm going to say is that science doesn't think systemically. It thinks about one cause, one effect. And here's a very good demonstration of this. So, what if you take atrazine and have a frog live in it? What do you get? You get a frog. No problem. It's safe. Yes. Tested it. It's safe. It's safe. What if you take atrazine and expose it to deadly radiation? What happens to the frog then? Now, first of all, how could atrazine ever be exposed to deadly radiation? Oh, the sun. Snap, I forgot about that, the sun. Damn it. Is there sunshine out in our fields where we're growing our corn and spraying 62 million pounds of atrazine? Oh, there is sunshine out there. Ooh, wow, maybe I should have tested for that. Maybe I should test for a lot of other things that we don't test for because that's not part of the scientific method. One cause, one effect, not systemic thinking. Systemic thinking says this. If I expose the atrazine to UV, it changes the molecular structure of the atrazine. It then affects frogs' immune system in such a way that nematodes are actually able to get into the frog tadpoles and cause genetic damage. Now, the atrazine doesn't cause this genetic damage. It simply weakens the frog to the point that the nematode can get in there, the little worm can get in there and cause this genetic damage. Right? And you've heard about DNA, yes? You've heard about DNA? Okay. So it's changing the DNA. The real bitch of this is, it doesn't just change the DNA. Your DNA is swimming around in this environment, right? The area around the DNA. It changes that so that the frogs, if you can believe this, have heart disease. Not only that, but that environment around the DNA is heritable also. And so the frog's children also have heart disease from the single exposure. This is systemic thinking. This is looking at how do things actually work in a complex ecological system. This is what I love about geography. This is why I became a geographer. I actually have a degree in business, finance. When I went back to school, I started doing economics, and I didn't like it. It didn't make sense to me. I started taking geography classes, and geography says, okay, well, economics is great, and so is culture, and so is politics, and so is the environment. And what geography asks you to do is put all 4 of those together. Think systemically, holistically about problems, and so we do this. So let's look at some other issues. Irrigation. When water comes off the mountains, quite often it has some dissolved minerals in it. Sodium, phosphorus, that sort of thing. You can't see it because it's dissolved. Can't taste it because there's not much there. But when you spread it on the fields in the San Joaquin Valley, well, the water gets taken up by the plants, or it evaporates off. Who takes up the salt? It stays in the soil. It stays in the soil. Do plants like to have salt in the soil? No, most plants can't stand to have salt in the soil. So as a result of salinization, we've lost, and this is 1995, this much cropland. And the numbers aren't important. What I want you to pay attention to is that land can barely be farmed anymore because of our irrigation. Now, does that mean we're going to continue to get more food from our irrigation projects? Or are we reaching the limit of that technology? Might we even see a decrease in irrigated lands, production on irrigated lands in the next 20 years? I would say yes. So the miracle of the Green Revolution may be reaching its limits. In fact, we may be looking at a decrease in food. Fertilizer. The number one fertilizer is nitrous oxides of various types, right? And where do we get nitrogen from? Anybody know? For fertilizer? What's a really good source of nitrogen? Chemistry majors in here, no. Did you know the air we're breathing is about 78% nitrogen? Yeah, it's mostly nitrogen. And we figured out a way using electricity and petrochemicals to break that out of the atmosphere, mineralize it, and then put it on our fields, right? So no shortage of nitrogen. The problem is that nitrogen is a greenhouse gas. This is adding to climate change. It's adding to the ability of the atmosphere to hold on to reflected energy. So we're getting warmer temperatures as a result. We're also getting these coastal dead zones. It works this way. Less than 8% of the nitrogen a farmer puts on the field gets absorbed in the plants. The other 92+% runs off into the water. Right? Goes down the Mississippi, whatever river it's in, out to the ocean, where it's food for plants. And you've got this alga floating out there, and the alga goes, whoop-hoo! We got a banquet here. We're going to get fat, have sex, have more of us. Yes! We're going to proliferate, right? Now, if you're a fish eating that alga, yes, this is great. I love this stuff. I love it. I love it. The problem is that not all these algae get eaten. Most of them don't get eaten. They die. It's sad. They don't live long. But there's bacteria that eat these algae. And so the bacteria go, yes, I love this. I'm so happy. There's dead algae all over the place. In the process of eating alga, they consume all the oxygen in the water. And if you consume all the oxygen in the water, then what does the fish breathe? Pause up. Yeah, dead fish. So we get dead zones. We get dead zones off the coast. Globally, dead zones look like this. Every river that reaches the ocean in the world that has agriculture upstream is starting to suffer the effects of dead zones, right? Too much nitrogen in the water, hyper-eutrophication. On top of this, in the 80s, we get a complete shift, and this is where globalization neoliberalism comes in. In the 1980s, under President Reagan and Prime Minister Thatcher, we get this idea that government shouldn't be doing this anymore. We need small government. We should let business do this, right? And Bill Clinton really pushed this when he was president. No, we're gonna stop funding the universities. We're gonna start letting companies like Genentech and Monsanto do the research, right? Because they're much more efficient, right? Universities, they're inefficient. Professors, they don't work very hard, do they? Okay, so we're gonna get a change. We're gonna get a change here. We go from having a food system to a food market. In a food market, anybody can enter the market and buy whatever they want if they have some money. If they don't have any money, too bad. So we get a defunding, we get a privatization, we get lack of access to these resources that we used to have. This fits into what happens with mechanization. Mechanization is efficient, but if you're a small farmer, you can't really afford to mechanize. You don't have enough land. And small farmers often have, the size of this stage to farm. So what are you going to do with that? Well, just to bring this home, about half the food produced in the world is produced by small farmers. And 800 million of those people do not have enough food to eat. The farms are so small, they cannot raise enough food for their family. It's supplemental. This is sub-Saharan Africa. If it's green, it's forest. Don't look at that. If it's red, it's a very small farm. Incidentally, this is about the size of the United States, okay? The area we're looking at here. If it's red, it's a very small farm. If it's yellow, it's a small farm. If it's dark blue, it's a very large farm. Do you see a lot of dark blue there? No. But if you look at this in 20 years, you're going to see a lot of dark blue there because there are companies from all over the world buying up land here, displacing small farmers to make big farms. And what are they growing? Palm oil and sugar for fuel. They're not even growing frickin' food, right? So where are these people going to get their food from? We'll see. This is not a third world issue. This is a developed world issue. So in Canada, what we have here, 1970, 2005, agro-food exports. Canadian farmers are rocking it. Look at how much food they're exporting. It's an enormous increase, right? This is net farm income for Canada. This is Saskatchewan farmers before they get their subsidy payments. Let's see, this is $0 of income a year, and this is a $20,000 loss. So how are farmers doing in Canada? These smart, Western, mechanized, modern farmers, how are they doing? Without subsidies, they're shot. If you're a Mexican farmer, do you get subsidies? Yeah, maybe 200 bucks a year, not $20,000 a year. Right? So problems with first word production. Why do not make any money? Because if you want to sell your beef in North America, you're going to sell it probably to Tyson, ConAgra, Cargill, or Farmland. If you're going to sell pork, you're going to sell it to Smithfield, Tyson, ConAgra, Cargill. If you're going to sell broilers, you're going to sell it to Tyson, Goldquist, and it's gotten worse, Pilgrim's Pride, and ConAgra. These are mostly privately held companies. They don't have to publish jack, totally non-transparent, and they all get together 3 or 4 times a year in martinis and talk about what the price of chicken is going to be this year for farmers. And do they want to pay their farmers a lot for the chicken? Is that how you make money? No, you drive the price down. You drive the price down. You drive the price down. Globally, farm gate prices go down and down and down. Farmers make less and less for the food that they make. And these guys make a lot from it. Privatization. We go from high-yielding seeds to genetically modified seeds. The problem with this is this. Farmers no longer buy seeds. They no longer buy chicks or baby pigs. They basically rent the seeds. They don't own them. They cannot do what they want with them. They can't even save them and plant them next year. It's against the law, against the contract. If you're growing chickens, you don't own the chickens. You're paid a certain amount to produce this many pounds of chicken in 48 days. That's how long you have them, 48 days, then they're ready to slaughter. So what we get now is farmers who cannot profit from their wisdom, and we get companies that are actually owning the life out there. Big problem for small farmers. And we're changing the climate. Problems there. So water stress. Think about your countries. Look at the map. Are you going to be water stressed? This is by 2025. This is just 10 years from now, right? If it's really red, you're going to be really water stressed. If it's really blue, you're going to be much better than you are now. Do you see a lot of really blue up there? No, there's green. There's places that are not going to get any worse. But there's a heck of a lot of red. And do you remember where we had the high consumption of plants? Consuming almost all plant material? Consuming almost all plant material? Well, production's going to go down because water's not going to be there. What about temperature? If it's red, that means production is going to decrease. Production is going to decrease as much as 50% drop in production because of temperature. Now, this doesn't include water. This is just temperature. And this is with a 3-degree Celsius world. So we're looking at 2080, something like that. This does not look good. We're also expecting more extreme weather events, right? So I like this chart. So this is baseline here, 1980. Red is earthquakes. Are we going to have more earthquakes? Does climate change cause more earthquakes? No, no, the Earth doesn't care about that. Are we having more damage from earthquakes? Yeah, because we're farming more areas. We're extending our area. So yeah, the damage goes up, but not more earthquakes. What about storms? We're going to have more of those? Yeah, we're going to have more of those. And this is not projection. This is fact. We're having more. More floods? Yes, we're having more floods. And droughts. Are we having more droughts? California? Yes, we are. Yes, we are. On top of that, we're screwing up the oceans. Because all the carbon we're putting in the atmosphere, some of that gets sucked up by the ocean. If you mix water with carbon dioxide, you get carbonic acid. And the basis of the food chain in the oceans are phytoplankton. These little plants, free-floating plants, and they have these little hard shells that keep them safe, right? That are made of calcium. And it melts so well, so easily by carbonic acid that we're looking at basically taking out the base of the food chain for the oceans. So no more whales, no more walrus, no more dolphins, no more nothing. That's what we're doing. Or salmon, or bass, or whatever. And because all of these things bad, all these negative things are not in the market can't address this. Right? This is all outside of the market. You don't pay for whales. So what can you do? What can you do? What's at stake? our biosphere. And right now, it's not looking good. Somebody I respect very much, I asked him what he thought the toll would be in human lives. He thinks about 2 billion people are going to die of starvation by 2060. That's in your lifetime. You're going to get to watch this if we don't change something. So one of the questions I asked you, the third question, is this. How can we use less of the world's resources in producing food, and what can you do to make that happen? Now, a variant on this question is this. How can we use less of the world's resources in producing food, and consider how you consume your food and what you can do locally or individually? And to that, I just want to add this. Annie Leonard talks about this beautifully. Go to her website. She's got a great video about the story of stuff. And there she talks about we too often think about ourselves as consumers. I'm going to change the world by how I consume, right? And what she's arguing is that you cannot do that. You've got to start thinking of yourself as a citizen. It's not about what you buy. It's about what you tell your congressman. It's about who you push on. It's about your political power. It's about acting in community. In the past, when rich people, when powerful people, when the elite started taking too much energy, too much wealth, too much food, too much of our biosphere, too much of our freaking money, the way we responded to that was not by buying stuff. It was by changing the law. This is about re-regulating elites. This is about law. This is what responds. This is how people respond. This is how elites respond, is regulation. It's up to us to re-regulate that. What can you do? Find something you believe in. Push on it. One thing you could do is say, we should have more agroecology. What is agroecology? Agroecology, I was just in Cuba, it's about growing food without chemicals. Because Cuba can't afford chemicals. They're doing it. And they're doing it by having, instead of pesticides, let's find some bugs that eat the bugs that are eating our plants. Let's find some birds that eat the voles that are eating our plants. Let's find some plants that discourage bugs from getting on our plants. So in almost every orchard I went in, I saw some little coffee trees. And they're not farming coffee. They're little coffee trees. Why would you plant a coffee tree in an orchard? And a guava / mango / something else, usually 3 plants in there. Why coffee? Do you drink coffee? Have you ever had coffee? Has anybody here ever had coffee? Yeah. It has caffeine in it, doesn't it? Yeah. What does that caffeine do to you? I just had some. Can you tell? Why does the plant make caffeine? Why does tea and coffee plants, why do they make caffeine? Because if a bug eats that, they get a stomach ache. It doesn't kill them. See, if it killed them, what you'd have after a few generations is the ones that didn't die, they'd be doing fine. They'd be having babies. No, it doesn't. It discourages them. If you plant a coffee tree amongst your other trees, it puts out this scent, and the bugs don't like it. They go away. Controlling life with life. Controlling life with life. This is agroecology. Does this work? Study in sub-Saharan Africa. We're looking at various things here, using bugs to kill bugs, how we sort of move our stock around, that sort of thing. And what we find is that in the studies, in almost all cases, we double food production without chemicals. We double food production, okay? Now, this is somebody's garden, big frickin' deal, right? No, it's 12 million hectares. I don't know what hectare is. 45,000 square miles. On 45,000 square miles in sub-Saharan Africa, people did agroecology and doubled their food production. Seems like a good idea, doesn't it? Right? What else could you do? Well, you could put pressure on our government to start encouraging non-export agriculture, growth for local markets. You could demand a carbon tax on all imports and all production in the United States. You can make mass transit work by frickin' writing it. If it doesn't work, then complain about it. That's how mass transit works. You got to start writing the darn thing or it doesn't work. Federal supports for new energy infrastructure. It doesn't work for local production of energy. You've got to change that. Challenge the legal right to patent life. Monsanto shouldn't be able to do that anymore. Stop it. Work on it. Thank the presidents, Xi, Modi, and Obama for finally signing meaningful agreement to decrease our greenhouse gas emissions. Or go to this website and see what's going on locally, right? The way to change this, the way to address this is to act. And the way to do that is to act together in community, and the way to do that and the time to do that is now. Okay? That's how we're going to change this. And if we don't do something, you're going to have a heck of a bad thing to grow up in. Okay? That's what we're looking at. Cheery. That's what I got for you. Questions? What are the questions for me? Are you going to read them? Okay. They're going to read questions for me. Come on up here.
The first question is, what should our generation do to help our environment in the future and help us starve by 2060?
Get politically involved. Get politically involved. Find something you believe in, start pushing on it. Enough people push on your representative, he or she is going to do something. If enough people push on our president, he or she will do something. But if you say nothing, then you'll say nothing. The only way to say something is to start talking. Get involved. It's important. Make a little time for it.
Without modern farming technologies such as pesticides, irrigation, etc., would we still have enough food to feed the world's tremendous population, assuming that affording the food wouldn't be an issue?
So I was just in Cuba this summer. How long does it take to make soil? Anybody know? That much soil? It takes about 100 years, okay? So I was in this farm, and what they were doing is they were putting cow poop and some other stuff in these great big bins with a whole bunch of worms. And in 80 days, they had 17 inches of soil. In 80 days, they had 17 inches of soil, basically worm poop, because that's what soil is. It's bug poop, right? It's full of nutrients, no chemicals. They were producing 400 tons of soil a year at this farm. No chemicals. Agroecology works. We know it works. It does not make Monsanto rich. They're going to fight it like hell. But it works. You can go to Occidental Arts and Ecology Center and take a permaculture class up there. Learn about permaculture. It works. It takes more energy. It takes more knowledge. You don't just sit on a tractor. Have you ever driven a tractor? I used to manage a horse rink, and so I would work the dirt now and then. You just sit there and go around. Farming can be brilliant, right? But we need to encourage that brilliance in farming. We have the knowledge to address this without chemicals, without Monsanto, without Genentech. We can do that.
Okay, second question for this card. What would a modern food system look like rather than the food market we currently have?
As much local production as possible. Now, if you live in Idaho, that's really sad if you just have local production, because in January, there's nothing growing up there, right? So within limits. But the idea that India is exporting 3 times more food than they're importing. India? Have you seen pictures of India lately? Lots of fat people there. Do you know why? There's not enough food. Yet they are exporting food. Does that make sense? No, it doesn't. It doesn't. We need to relocalize, at least on a national level, on a regional scale if possible. That would be modern. More direct consumer to grower purchasing. Farmers markets, that would be more modern. Oliver's Market, which really tries to source local producers. That would be more modern, right? Postmodern, maybe. Postmodern. The idea is that you start buying food that is as locally produced as possible. And does it cost more to buy food at farmers markets? Guess what? That's how much food costs. You know what? If you're not paying somebody from Mexico or Guatemala 40 cents an hour to pick your tomatoes, that's what a tomato costs. That's what it costs, right? Food costs something. But how much of your budget is that? Oh, I'm going to spend $100 this month instead of $80. It's not that much. It's not that much. But the change is huge. The change is huge. But you got to decide to do that. And write your congressman. Call your congressman. Email your congressman. Yes?
Is there a chance that we could start running out of food for the growing population?
Is there a chance we could start running out of food for the growing population? Yeah. It looks like we are reaching the limits of a lot of our technologies. Now, we have Monsanto and Genentech and some other companies making seeds, right? 96% of all patents filed by those companies have been to resist their pesticides. I figure out how I can make corn resistant to Roundup if I'm Monsanto so I can sell more Roundup. It's not about making the plant produce more. It's not about making the plant more drought resistant, salt tolerant, nothing. Almost all the patents for that have been filed by universities, like Davis, that are still trying to make more food without making more money.
How can the corporations be taken off their pedestal? How do we fix this?
Law. It's got to be regulation. It's got to be regulation. It's got to be regulation. And I really do think we have to start changing how we think about ourselves. We have to become more systemic thinkers. We have to think beyond just what I can observe. And we have to keep that in mind. The reason that global change, climate change is so difficult for people is that it's so abstract, right? It's 30, 40 years down the road. It's so abstract, but it's real. It's there, right? Your old age is abstract too. Stop that right now. Ladies, stop that. Reflex reaction. What was the question?
How can the corporations be taken off the
Regulation, regulation. The way the United States stopped wage slavery in 1800, early 1900s, was through the union movement. We changed, Americans changed the laws about labor. We did that. We did that. And as a result, from 1945 to 1970, we had a blossoming middle class. It was lovely. And since then, we've deregulated labor regulation. Unions have gone away, and you know what's happening with the gap between the rich and the poor in the United States, right? We've deregulated. Thank you, Bill Clinton. Thank you, President Reagan. Regulation, laws. I'm all about laws. I'll admit it. Yes.
How can the world be shown that we're destroying the biosphere?
How can it be shown that we're destroying the biosphere? With PowerPoint shows. So I talk to as many groups as I can. I teach this stuff. I'm starting a new class next year about society, environment, and sustainable development, where we're going to look more carefully at this. Hopefully, some of you folks are going to be inspired. You're going to make some neat videos that get posted on whatever the latest social media is, and people see that. That's how we're going to do it. But we've got to get young people involved. We've got to get you involved. That's why I teach. This is the most important thing I could do in my reckoning, was try to get some of you folks to care about, to become involved in this. I'm not that good an activist, but I like doing this. Find something you're good at. Find something you like to do that can help people realize what we're up against here.
Is there any one company and country more at fault or to blame? Or who is most harmful?
The United States. The United States. We have led neoliberalism. We have led deregulation. We have led the deinstitutionalization of world government and economies. Put most of that on Bill Clinton, but we continue to do it. We continue to do it. Company, Monsanto. I mean, Genentech, some others are involved with this, but Monsanto holds the majority of the patents. They're the ones selling Roundup. They're the ones incorporating, privatizing life. But now we've got companies like Smithfield, I just showed you. They were just purchased by a very large Chinese company. They are now the largest hog producer in the United States, and they're doing the same thing, the contract farming, right? And so your hog, you know what a gestation pen looks like for a hog? You know, hogs are pretty big. Gestation pens, gestation, what's gestation? That's when you're pregnant, you're making the babies inside you. Gestation pen allows a pig to do this. That's all she can move. For 3 months, because it's efficient, right? That's not a way to make meat, folks. That's not a way to make meat. It's not just Monsanto. It's this whole idea of how we're making our food. We can do so much better than this. Do we have time for one more? No more questions. Oh, there's one up there. Yes. The label organic has become very problematic because in California, these people who wanted to do permaculture, family farms, no chemicals, well, they wanted to call that organic. But some big guys wanted to go organic too because there's value added in that. What's happening in California now, to be an organic farmer, there's this checklist of chemicals you don't use. There is a checklist of chemicals you can use. So we get all these farms using some bad chemicals. Another thing you can do is, well, I'm not going to farm this for 3 years because they don't have any water. But on the 4th year, I'm going to farm it organically because now I'm going to put water to it. And no matter what I've done in the past, I can call that organic because I've gone 4 years now. But that doesn't mean I'm farming organically, right? So organic, it's problematic. So that's something else we need to reform. Julie Guthman has an amazing book about this, if you want to read this. She's at Berkeley, Julie Guthman. Yeah, good book on organic. We're out of time, folks. Thank you for your attention. Take care.